All right, now we'll get into some examples with solving exponential equations. Okay, so let's dive right in. We're going to do a few of these, starting with starting about as simple as we can. So let's say here, part A, 3 raised to the x equals 81. So the solving equation, that's really going to be our focus in this chapter. And so here, like, okay, so I've got my exponential here on the left. I've got my base of 3 raised to a variable equals some number. Okay, and obviously our goal is to figure out the value of x. Now this one is simple enough that you might even know it right away, or you might be able to guess and check your way. 3 raised to what is going to give you 81? Okay, but I'd like there to be a procedure for us so when things get more complicated, we don't have to rely on guess and check, right? So here's what we're going to do. On the left side, I have a base of 3. So I'm going to rewrite the number here on the right side as having that same base. So I'm going to think to myself, 81. 81 raised to what power? Or excuse me, 3 raised to what power would give me 81? And I'm not sure. So I'd grab my calculator. Hey, is it 3 raised to the third power? Well, 3 raised to the third turns out is 27. Is it 3 raised to the fourth power? Oh, 3 raised to the fourth is 81. Okay. So here's my note. I'm going to rewrite 81 as 3 to the something, and there I'm just kind of going to guess my way to it. So here it is. So I'm saying, okay, 81 I'm going to rewrite as 3 to the fourth. And this 3 to the x just gets copied over. Now if I look at this statement right here, 3 raised to the x equals 3 to the fourth, don't these exponents have to equal one another? Doesn't x have to equal whatever numbers over here? I mean, if I just compare the two sides, 3 raised to something, 3 raised to something, those somethings have to be the same, wouldn't they? I mean, logically, right? So I can conclude, okay, x must equal 4. Got it. Now, this procedure here probably feels like complete overkill. Maybe you even knew that back here, like, oh, well, 3 raised to the 4 is 81. We've talked about that sort of thing before in this course. Okay, you're right. But now let's move on to something more difficult, like this. So I'm going to change it up a little bit. 3 raised to the 2x plus 1 equals 81. Now I've got something a little bit more complicated than just x alone in that exponent. 3 is being raised to that whole thing, 2x plus 1. We'll still make it equal to 81, give us a nice smooth transition into these problems. Okay, so when I see this, I say, all right, my base here is 3. So I want to rewrite this 81 with a base of 3. 3 raised to what? Well, obviously we've already thought that through. It's 3 to the fourth. So I'm going to write this. Okay, I'm just copying the left side here. And now I write the 81 as 3 to the fourth. Okay. So then that same logic comes in. Whatever this exponent is, doesn't it have to equal that number? I mean, come on, just compare the sides. These have to be the same. So I'm going to write 2x plus 1 equals 4. That's my next line, because I can just tell, looking at this, those have to be equal. I mean, the other parts match up, so these have to match up for this to be true. And now what's interesting is I didn't do something to both sides from this line to this line. I just realized that has to equal that. And so I wrote it almost like a brand new equation. Okay. Well, if it makes sense that 2x plus 1 must equal 4 from that previous line, then we're just a couple steps away, right? We can subtract 1, we can divide by 2, and we can have our answer. X equals 3 over 2 here. And we got it. Now, if we wanted to check ourselves, we could plug that answer back into the original X. and just go ahead and see if that really works out. If we do, I think we can maybe even do this verbally. 3 over 2, plugging in there, well, 2 times that, the 2's would cancel, and we'd have 3, and then 3 plus 1 is 4. So 3 to the 4th is 81. Yeah, it would work out. Okay, let's try one more before we switch topics here. Let me erase what I had written there on my yellow page. All right, so we're going to change things up a little bit here. Getting a little shadow there from my page. Okay, 5 raised to the x squared plus 3x equals 25. Now my exponent, it's a quadratic, right? X squared plus 3x up there, that whole thing equals 25. Okay, but that's going to come a little bit later. The first thing we notice is, hey, I've got a base 5, so I want to rewrite this as 5 to the what? And well, okay, 25 is 5 to the what? And well, and we've talked about, squares and powers, quite a bit in previous chapters. Fortunate for us, so yeah, let's go for it. Oh well, I wrote it again there. Okay, 25 is 5 squared. All right, there we go. So 5 raised to the x squared plus 3x, and rewriting is 5 to the 2. So then from here, I say, my base is 5 on both sides. So those exponents, those have to equal one another. I mean, if you just compare the left and the right sides, these have to match. So I'm going to write that as my next statement. All right, x squared plus 3x has to equal 2. And then, well, whatever means possible, I'm going to go ahead and solve that. And, if we were in class, this would be a lot more interesting. Is I'd say, hey guys, what are we going to do from here? And well, hey, we just had a test on this stuff. Here's what we're going to do. We're going to subtract the 2, make it equal to 0, and we're going to go for a quadratic formula on that quadratic equation. X squared plus 3x minus 2 equals 0. So I've got my values of a, b, and c. All right, 1, 3, and negative 2. Going to go ahead and plug those in. Negative b plus or minus square root b squared minus 4ac all over 2a would look like that. And it turns out there's really not a whole lot to do to simplify here. If you simplify what's underneath that square root, you get 17. And okay, well, 2 times 1, I guess, is 2. We really can't go any further from here, so I'm just going to go ahead and leave it like that with that plus or minus. So it turns out there's 2 answers, one where you add, one where you subtract, but neither one of them are going to come out nicely, so I'm just going to go ahead and leave it just like this. Okay. I think that's all we're going to do here in this video. We've got another concept coming up in part 3.